one of the things that you kind of touched previously was that there is this sort of HTSR, heavy tail self regulation,
Right.
right? So, can you kind of tell a little bit about how there's a fingerprint left on the data model and explain that concept to our audience in
Right.
very basic, simple
Right.
terms?
So it turns out when you train, so people don't understand how to train models. So they train these models, and the big guys, yeah, they have a lot of money, right? But the theory of training models is not very well advanced. So what happens is if you're trying to train or fine tune your own model, if you're fine tuning your own model, you're training one from scratch, it turns out that we've discovered there are certain scientific principles which govern how the layers converge. And you can think of the model as sort of like a cake, a layered cake, lots and lots of layers. And as you train it, you're baking a cake. Well, what happens is when you bake a cake, you got to get the temperature right. Or maybe in Texas, you're you know uh you're cooking a brisket, right? And when you cook a brisket, right, you have to get the temperature just right so that the fat will melt into the meat. And if the temperature is too hot, you cook the meat, but it kind of gets burned. And if you don't cook it long enough, then the fat really doesn't melt in and you don't get that really tremendous Texas, barbecue flavor. And it's the same idea that when you're training a model, you're basically smoking it. You're baking a cake. You're cooking a brisket. And as you're doing that, you have to the layers. You think of the model as like the different layers. You've got the meat, you've got the fat, you've got the collagen, you've got the seasoning on the outside. It all has to cook at the right temperature in the right way with the right airflow. Otherwise, it doesn't come out right. It's the exact same thing with these models. And what happens is certain layers, the models exist, they're like layered cakes with lots and lots of layers, maybe 100 layers.
Wow.
And the layers don't converge. So, like, the inside is not quite cooked and the outside is too crisp. That's what's going on. And Weight Watcher watches the weight. So, as you're training, it will watch it and it will help you figure out how to train it in a way. It's like a temperature thermometer. It's like a
Yeah.
thermometer, or, or an x ray machine for the model. That's
Yeah.
what's going on. That's what it does.
Yeah. So it's essentially trying to detect which data is good data and which is not so good data,
It,
and trying to correlate that between what is useful for the model.
well, it doesn't need to look at the data. It
Yeah.
just looks at the weights. By
Okay.
just looking at the weights of the model,
Yeah.
you can figure out whether the model is being trained correctly or not.
Okay.
That's the key, is that you're just looking at the weights.
Yeah.
And that's it's very surprising to people that you can do this, that the weights contain all the information. Well, they don't contain all the information, but
Yeah.
they contain enough information that you can figure out you can get a broad level idea of what's going on.
Yeah.
And that's the magic of the tool.
Yep. Yeah. So it's essentially making sure that like the right thing is weighted correctly. It's not over or underweighted, and making sure that that is what the model is using essentially.
Right. That's right. Yeah, making sure that, so like in grokking, what happens is the models tend to people think the model memorizes its data. But there are different ways of memorizing. You can memorize the data and not really and you can memorize the data without being able to predict anything. But that's kind of like an ethereal memorization, a transient memorization, where it's different than when you have this sort of overfitting, where you overfit the data, where now you kind of get caught in a loop and you just keep making the same predictions over and over and over. So there are cases where the models will just make random predictions and they're just kind of noisy and they do random things. And then there are cases where you kind of get caught in a loop and they just repeat the same thing, or they make the same mistakes over and over. And that's sort of what the tool can detect, which kind of bad memorization the model is doing, and layer by layer. That's what it's for. So it's really for specialists who are trying to train their own models, or maybe you're training a model and you want to give. Maybe you're training a model for like a robot, and you want to give that model to the people making robots, and you want them to have some confidence that the model's not completely, that doesn't have any weird problems. So Weight Watchers kind of a consumer reports tool that lets you tell your customers, "Oh, I built this model for you. Let's run it through the tool. Now you can have some confidence that the model is going to work correctly without having to do lots and lots of expensive evaluations."
Yeah, like a kind of like a grading system. Like, okay, yeah, we give your
Grading system, yes,
A or B or C kind of like how good it is, and giving it a general score, sort of.
yes,
Yes. Okay, that makes
that's what
sense.
it's doing,
Yeah.
and that's the idea. And so we work with people who are training models for other people, maybe
Yeah.
for robotics, maybe for medicine, and they want to just have some confidence that, you know, they want to look for problems early. So you catch the problem early on so you can go back and review your training process to make sure there wasn't some weird problem.
Gotcha.
That's what's going on.
Yeah.
So like an early warning system.